Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Hello and welcome back to the problem 3-25. So in this problem, the acrylic plastic rod is 200 mm long and 15 mm in diameter. If an axial load of 300 Newton is applied to it, determine the change in its length and change in diameter. Modulus of elasticity of this rod is given and Poisson ratio is given, which is equal to 0.4. So let's start with the given data. So it is given that this is an acrylic plastic rod here having length is equal to 200 mm. Diameter of this rod is equal to 15 mm. Clear? And load P is equal to 300 Newton is applied. Also, modulus of elasticity EP is equal to 2.70 gigapascal, which is equal to 2.70 into 10 raised to the power 9 pascal, and Poisson ratio VP is equal to 0.4. So what we have to find is, the first one is to find the change in its length. So we have to find change in the length of this pipe. And the second part is change in its diameter. So we have to find delta D. So let's start with the solution. First we are going to find the change in length, and we know that change in length is equal to strain into original length, because we know that strain is equal to change in length divided by original length. So from that we can get change in length is equal to strain into original length. So how we will find this change in length? Again, you can see that change in length contains the strain and original length. Original length is present but strain is not available. So we know that from Hooke's law that stress is equal to strain into modulus of elasticity. So from here you will get the strain is equal to stress over E. Now again, E is available, stress is not available, so stress can be found by using formula P over area. Load is given and area can be found by using the diameter. So P is equal to 300 Newton. Clear? And area is equal to pi by 4 d square, and d is 15 millimeter, so you have to convert it into meter, which is equal to 0.15 whole square. So when you solve this, you will get the stress is equal to 1.678 into 10 raised to the power 6 pascal, which is again equal to 1.678 megapascal. Now you have this stress, you have the value of E, you can put it in this formula and you can get the strain. So stress is 1.678 into 10 raised to the power 6 divided by E is equal to 2.70 into 10 raised to the power 9. So again, if you solve this, you will get the strain value, and this strain value is equal to 0.000628. Okay, so you have now strain. You can go back and put it in this formula, that elongation is equal to strain into original length. So strain is 0.000628 and original length is 200 millimeter. So from that you will get this elongation, which is equal to 0.126 millimeter. 126 millimeter. So this is the answer of our first part, that is to find out the strain. Clear? Now we will move toward our next part, and in next part it has been asked to find the change in its diameter. Okay, so how you can find the change in diameter? So for that we have been given mu, which is equal to Poisson ratio, and that the value of mu is 0.4. Now we know that this Poisson ratio is equal to strain in lateral plane to the strain in a plane that is normal to the lateral plane, means elongation in that normal plane. So what we have this value, we have this value, we can find the lateral strain. So lateral strain will be equal to minus mu times into epsilon. So mu is equal to 0.4 and epsilon is 0.000628 multiplied by 0.000628. So from here, when you calculate it, you will get the strain in lateral plane. So strain in lateral plane, after calculating this, comes out to be minus 0.002515. Okay, so you have this strain. From this lateral strain we will calculate the change in diameter. So this lateral strain is equal to change in diameter divided by original diameter, and this change in diameter is equal to final diameter minus original diameter divided by, this is original diameter, or you can simply use this equation as well here. So you have this lateral value which is equal to minus 0.002515 is equal to change in diameter divided by original diameter, and original diameter is 15 millimeter, which is given above. So when you solve this, you will get change in diameter is equal to minus 0.00377 millimeter. Now here the change in diameter is minus 0.00377 millimeter. It means that due to this tensile load, the diameter will decrease, and the change in diameter will be equal to minus 0.00377 millimeter. So this is the answer of our second part. I hope you have enjoyed this video. Thank you for watching.